Hello, everybody. I'm Marianne Ruijs, working for Fluitech Team Europe, and I'll be your moderator for this session. I'm very glad to introduce to you Erik Mosselaar, Business Development Manager at Distance Oy, and he will be sharing information on conditioning monitoring, driving progress toward sustainability goals. Enjoy.
In this session, I want to talk with you about a few facts around how our industries relate to global net zero goals. I also hope you will gain some practical insights into how we can make a positive impact by simply to keep doing what you already love doing, delivering reliability. In fact, when correctly applying these methods, this actually creates more time on your schedule rather than less. And as you will observe, reliability, efficiency, and sustainability are almost automatically results of choosing your tools wisely. All right, let's go. Climate change literally is one of the hottest topics today across cultures, age groups, professions, and continents. It doesn't matter who you are, where you are, I'm pretty sure you're familiar with it. That the sense of urgency is alive in most of us can be observed in many positive signs towards mutual goals all around. And signs are those of a growing global commitment to net zero emissions. Almost everyone seems to pick up on the responsibility personally and does their bit. Now, besides all our individual contributions, many manufacturing companies too are answering the call for corporate social responsibility and are driven toward developing their own organizational sustainability goals. After a COVID-related dip in 2020, according to the International Energy Agency, energy combustion and industrial processes accounted for nearly 89% of energy sector emissions in 2021. Emissions from the world's power plants reached their highest recorded level so far. This presents a massive opportunity for industrial organizations to make a positive impact. Once it is understood how production and operation processes contribute to the problem, it becomes clear where positive impacts can be made and what tools exist to make the transition a success. Let's look at a few of them in the next minutes. Hi, I'm Erik, and I'm your host for this talk. Together with our team, I help build and nourish partnerships that deliver collaborative advantage and precision services across industries. Of course, at the end of this session, you can ask me anything or talk about suggestions that you feel should have been included here. But I'm always open for a chat by phone or mail too, or just drop me a note on LinkedIn. All right, in this session, I'd like to introduce a few thoughts. We'll talk about the impact of sustainability strategies on the industry and how to balance between answering the market demand and emission reduction. Then we'll elaborate a little bit on actionable suggestions that can help reach sustainability goals. We'll also talk about what's under the bottom line, how cost savings can go hand in hand with these goals. And then when we're done, we hope you'll have a better understanding of how modern technology can and proper strategies can help us to reduce our inevitable footprints on our planet, and how manufacturers can use condition monitoring tools to take action on sustainability goals. Back in 2015, the UN Department of Economic and Social Affairs has presented 17 sustainable development goals as part of the 2030 Agenda for Sustainable Development. The ones related to energy and emission reductions and of particular interest to manufacturers are these three. Sustainable, reliable, modernized energy is to be accessible and affordable for all. Feasible, economical, and industrial advancement are to be promoted, and all of us must be the forerunners of change. Now, the call to action for the global community includes slowing climate change in general, creating sustainable and safe conditions for all people, and ensuring that manufacturer and consumer behavior supports these goals. These may seem massive undertakings at first, however, they are necessary. So huge goals, yes, indeed, but the world responds in impressive numbers. According to the Glasgow Climate Pact in 2021, over 90% of the world GDP is now covered by net zero commitments. I think that is awesome. Manufacturing will always require energy to produce the goods we need in all areas of our lives. However, with investments in more sustainable processes, manufacturers can reduce their contribution to emissions, and with that, the carbon footprint. Organizations that want to take the lead in finding solutions need to focus on managing assets for optimal machine condition and longevity. After all, healthy machines are more productive and efficient while consuming less energy. With this notion in mind, it can be said that the manufacturing industry has ample options at hand to increase sustainability and decrease its carbon footprint. More than merely participating, each manufacturer can become a driver of net zero goals as they find ways to implement more sustainable strategies across the industry. As we've talked about earlier, manufacturers are per definition heavy contributors to emissions and waste. The good news in this is that the steps we can take towards sustainability goals automatically hold potential to result in a significant reduction of emissions globally. Let's take a look at a few areas where manufacturing contributes heavily to global emissions and why these present critical opportunities for change. The efforts you make in each category can help reduce your facility's carbon footprint. Now let's start off with some facts on power generation and CO2 emissions. Power generation plants emit carbon dioxide, and the more demand for power, the more emissions are created to meet that need. Pretty simple. According to research, the industrial sector contributes 17% of emissions globally, making the industry a vital part of any meaningful solution to our climate crisis. As a result, this is a key area in which manufacturers can lead, as exploring options that correspond with organizational goals for productivity and sustainability will allow you to be a leader in the manufacturing industry. One quite obvious way to reduce emissions is to convert traditional electricity generation methods to greener ones and switch to renewable energy sources as much as possible. Now, switching to renewable energy sources is a highly effective way to bring emissions levels down, and efforts on this front show steady decreases. This brings us to a second high impact option: to increase the energy efficiency of the electric motor driven systems across the various industries and equipment types. Let's explore this further. According to the World Energy Outlook report released by the IEA, our global hunger for electricity will grow by over 76% over the next 3 decades. By 2030 alone, our demand is estimated to grow 26%. Now, these numbers need to decrease for communities to reach net zero commitments. Also, according to the IEA, industrial sectors consume 42% of the global electricity. And a large portion of this demand is created by electrical motors that drive our manufacturing and production processes, which means efforts to embrace more efficient electrical motor-driven systems, or EMDS, can help reduce consumption. Increasing the energy efficiency of the EMDSs already being used in facilities and driven equipment is a good strategy to explore. Boosting the energy efficiency of EMDSs with new motor technologies and more energy efficient components could decrease the power consumption by approximately 25%, according to reports from the IEA. The overall effect of that is enormous. The accumulated power demand across all continents could be reduced by 10%, making it an opportunity for manufacturers with sustainability goals and those backing projects that optimize EMDSs for energy efficiency. In addition, when EMDSs need less energy to run, overall demand will drop, cutting needs for power generation itself. So around 10 years ago, approximately 66% of the power in industrial applications was consumed by EMDSs, with electric motors in general consuming 43%, according to the IEA. What the exact numbers are today, I wasn't able to retrieve, but based on these numbers, this means nearly 1/3 of the power generation plants on the planet exist to keep electric motors running. And that's almost 1 out of every 3. Improving the efficiency of these systems with condition monitoring and prescriptive maintenance can make a substantial impact. Machines not running at peak performance tend to consume more energy and work less efficiently, and therefore, every effort to pinpoint issues before they become critical can impact sustainability goals. For example, according to recent studies, a common case of misalignment can lead to about 3% energy loss. To further illustrate this impact, let's take a closer look at a common piece of industrial equipment. With, according to Grand View Research, a global market value of over 60 billion US, industrial pumps are widely used. In this example, taken from 2013 research in Egypt on common centrifugal pumps in the water industry, findings are that extensive vibration levels at high frequencies caused by rundown bearings increase the energy consumption while simultaneously decreasing the pump efficiency. At 85% increased bearing vibration levels, the research pumps consumed 14% more electricity while dropping 18% of their production capacity. So in this example, with up to 14% increased power consumption, it seems there is a window of opportunity where accurate maintenance can decrease the industrial electricity consumption and decrease its carbon footprint along with it. The 18% capacity drop also means the production loss will likely to be compensated by increasing either production time or speed, which means an even further climb in electricity consumption and carbon footprint seems thinkable. With efficient online condition monitoring, you can promptly identify and resolve or prevent these issues. After all, knowing what will fail and when it will fail not only means knowing which resources are needed where and when, but increasing energy consumption can be derived just as easily and timely. Another topic to address here relates to the circular economy. Sometimes opportunity lies in shaping new perspectives in asset management and procurement. For example, manufacturers who are willing to examine how and when they replace components can make an impact by reducing how many new parts they need to use. Machine refurbishment is a common practice across industries, and remanufacturing or refurbishing products is an emerging trend in industries mainly used with custom parts, such as custom bearings. Having said that, there is an increase in refurbishment cases for standard components too. Now, this approach can have quite an impact. According to well-known bearing manufacturers, refurbishing the bearing consumes up to 80 or 90% less CO2 compared to producing a new one. So a consistent effort on this front can significantly cut carbon emissions over time. To compare, 100 kilograms of reworked bearings will save approximately 350 kilograms of CO2 emission, so they state. The difference mainly seems to come from less need for energy input, reducing raw material consumption and waste. And as a side note, they also agree that this practice cuts costs and reduces lead times. As one of them says, Repair the same bearing twice, and you could cover the cost of a new bearing. Now, that should speak to your wallets, right? However, to balance well, you'll need to monitor carefully, accurately, and around the clock to ensure that you replace parts early enough to salvage and refurbish them, while still using them long enough to not create more waste with all the good intentions. Online monitoring with high accuracy systems can provide these insights against a workable time frame. Now, when it comes to maintenance execution, early anomaly detection leads to smaller corrective or preventative actions and are often minor and quicker to execute compared to late-stage discoveries. This means less resources consumed by repairs. Also, collateral damages or collateral equipment damages resulting from late-stage actions can be avoided, including additional costs and resources used. However, merely responding to critical maintenance issues isn't enough to shift consumption and emissions levels. A proactive approach allows you to perform minor repairs more quickly based on correct information provided at the right time. Monitoring equipment online provides accurate data and analysis to keep machines in top condition and reduce downtime and resources involved. Another significant driver of greenhouse gas emissions is caused by industrial consumables such as industrial oil, for example, lubrication and hydraulic oils. When working on cutting both energy consumption and emissions, companies need to investigate every step of the manufacturing process. For instance, major oil companies agree that oil recycling makes environmental and economic sense. The manufacture of lubricating oils is the most energy-intensive process in a crude oil refinery. This white paper states, and used lubrication oils are often burned in industrial or commercial boilers, which releases multiple pollutants, including carbon dioxide. With new technology, however, the base oil of a lubricant can be re-refined to remove water, contaminants, and additives, so to prepare it for a new life. Another change in perspective allows facilities to shift their thinking regarding consumables and instead thinking of them as assets with an extendable lifespan. Instead of simply exchanging the oil, you can reincarnate the oil by filtering and cleaning it to repurpose it. Filtering and cleaning oil so it can be recycled is a growing trend, as the production of oil heavily impacts carbon emissions. Recycling 1 kilogram of oil, for example, saves 3 kilograms of carbon dioxide from being produced. So before it gets to re-refining, extending lubrication oil's useful lifetime by filtering and cleaning reduces global warming potential, acidifying potential, and human toxicity potential with around 90% after the installation of a lubrication oil filtration system, according to research. According to this university's calculations, in their example, filtration results in just under 12% of CO2 emissions compared to 4 oil changes per annum on the same system. To achieve such results, you will of course have to know exactly what the optimal time is for filtering, cleaning, or other related actions. This is where automated online systems can be of great help. Careful monitoring of oil assets can help manufacturers maintain oil condition and quality, and therefore promote machine health and with that sustainability. Not only does such a toolbox provide precise 24/7 insights in the oil quality and contamination itself, but it also indicates degradation and points towards the root cause. And certainly, when combined with highly accurate vibration monitoring in the same system, sudden particle bursts, for example, can be matched with registered anomalies in, let's say, a gear mesh to help perform a more accurate RCA. It can also enable you to cut the number of samples that need to be taken and processed in a lab, which relates to the previous topic on resource management, as well as waste management and environmental impact. Being assured the oil as an asset is in good health, you know exactly when to draw a sample and when not to waste time and resources, and you reduce collateral environmental damage as you go. Find more on these topics in my 2021 contribution to the LRVS platform, as well as on the Distance YouTube channel. Again, today, oil is an asset, no longer a consumable. So far, when talking about waste, we've addressed waste from the maintenance point of view. Resource waste, waste caused by components beyond repair, and waste caused by neglected oils. But production processes running under less than optimal conditions due to unhealthy machines can impact product quality as well. And flagging areas where waste occurs in a manufacturing process creates opportunity. Partial or complete production shutdowns for maintenance and then ramping back up afterward typically cause waste of energy or raw materials and can cause quality issues or batch loss. Keeping machines maintained and mitigating downtime is key to keeping productivity and profitability high. Monitoring equipment online provides accurate data and analysis to keep machines in top condition and reduce unnecessary waste and environmental impact. Manufacturers are beginning to act more quickly as these transitions increasingly become a necessary part of their planning. If you are willing to be proactive on sustainability goals, you are likely to benefit from the long-term rewards of these initiatives. For example, you're probably doing regular measurements through manual inspections to ensure proper maintenance management. When your staff reliably executes these routines, it can appear that operations are running smoothly. However, there is a growing recognition that finding better ways to carry out production tasks is better for the organization. Remote monitoring systems allow for closer and more accurate monitoring of entire facilities. And these systems can increase sustainability and reduce organizational costs by reducing travel time and energy consumption, limiting costly downtime, and improving product quality and production efficiency. So developing energy efficient options is just one way to cut emissions. A vast opportunity lies in addressing how your existing machines are used, monitored, and how they're maintained. When assets and components are cared for properly and timely, they can produce more, consume less, and last longer, accumulating in decreased carbon footprints and increased sustainability. Now, there are ample tools on the market to support and help you achieve this in a user-friendly way. Carefully selected tools can monitor asset health across your fleet of machines and help you make the right decision about sustainability efforts. But then again, no matter how wonderful the technology, it will always be you and your processes, your work ethics that make the real difference. And there's no doubt all of you here are committed to delivering reliability. I'm sure this is an open door I'm kicking in here. Anyway, hats off for making a difference. Thank you very much for attending. I hope this is helpful for you in some way or the other. And of course, heaps of gratitude to LRVS for providing this opportunity to interact with you guys. So let's see some questions or remarks, please. Happy to help.
Well, thank you so much, Erik, for this interesting session. We still have a couple of minutes time left for questions. And there is one coming up right now from Pierre. Erik, hopefully you can read it and and answer the question from Pierre.
Yes, I can. Let's see, which advices could you give to someone who wants to start an online condition monitoring program? Um, well, the first thing you do is, I think, evaluate what is it you're actually after. What do you want? There are so many solutions on the market. It's difficult to navigate that vast forest. So you would start with in mind what is the result that I want that I want from this, and what is actually the equipment, the assets that I want to monitor. So that would determine the methods you use, and that then determines what technology you want to use to support your strategies. Does that answer your question a little bit?
Okay, thank you. Thank you, Erik. I have a question for you, if I may. You keep
Sure.
referring to online monitoring of vibration, oil, and other metrics. Are these measurements based on your own sensors, or what?
No, not at all. Although the edge terminals are our own design, the technology is entirely sensor agnostic, and that means the user can connect any suitable commercial sensor to the terminal, and this is where the magic happens. That also means that they can very simply put semi-fixed monitoring installations online or hook up retrofit situations, and they can mix multiple monitoring methods. And this also means that when sensor technology evolves, you simply connect a different sensor that follows your wants. And we don't have to periodically reinvest in R&D to do this either. It's already.
Okay, thank you. I have another question.
Thank you.
When talking about extending the component lifetime, surely lubrication is important. How do you indicate this?
That's a great question, actually. The Condense is actually the only automated online system in the world that looks at friction in an accelerometer sample. And because we sample at 48 kilohertz, 24 bits, and pre-analyze on the edge in the range of zero point 0.5 hertz to 23.5 kilohertz, we already had the correct data sets for this. And then together with the Finnish university, we developed a feature that looks at the sample from a different angle and automatically derives needs for grease from friction without having to add different types of sensors. And this way, you can still turn your time-based lubrication schedule into a need-based one. Is this what you're after?
Yes, thank you so much. Okay, our time is almost up.
Thank you.
So thanks again, Erik, for if there are no other
Yes.
questions, I
Hi.
think they have all been answered. Questions have been answered. So many thanks for your time and have a nice day.
Hi.
Bye
Thank you
bye.
very much. Hi. Cheers.
You're welcome.